this presentation very technical. I thought the audience is going to be a lot more about developers and technical people. So I'm going to talk. I'm going to turn it a bit more generic and talk about the zero knowledge proofs in general, like how they are going to affect all of the blockchain space. So you might be familiar with this idea of the scalability trilemma, that essentially the systems we have can be improved in one of these three aspects, and it will necessarily make some sacrifices in the other two, or like at least in one of them. And this used to be true since the invention of Bitcoin, since the days of Satoshi. And you know, you have our mission with zkSync is to make blockchains available to everyone in the world. And I think that we all kind of share the aspiration and the hope that this will happen, and every person who has a cell phone, some access to any type of hardware will be able to access blockchains, have fully permissionless right to participate in this economy. And if that's the final goal, how are we gonna deal with this thing? What we're gonna do? There are maximalists who believe that only one chain will survive, everything is gonna be on Bitcoin, and all the side chains of Bitcoin will do the scaling and will do smart contracts. Ethereum maximalists believe that Ethereum will prevail. There are ecumenists who believe that we're going to live in a multi-chain world, and all the different blockchains, one blockchain cannot rule them all, so we'll have a lot of different networks which are interconnected. The technology is called zero knowledge proofs. It directly, immediately, today allows us to scale computation, to scale the validity aspect of blockchains. We cannot yet scale the data availability. So these are two different parts that needs to be scaled to give everyone, all of 10 billion people who are going to comprise the population of the world, access to blockchains. But we can do, you can take all the financial transactions of the world that are happening within a day or a year and compress them to a very short, very succinct message of a few kilobytes. And this message can be verified from any cell phone within 30 milliseconds. Imagine that. It's unfakeable. It's just as good as your signature if you use to sign Bitcoin or Ethereum or whatever transactions. And it's here. So it's been used so far only for privacy in technologies like Zcash and Monero and other private coins. This would be already sufficient to scale Ethereum, to get to the throughput rate of let's say Binance chain today. In the future, this won't be enough because we saw last year on Ethereum that the transaction fees are growing super linear to the number of users who are coming to the blockchain. Because the thing is called induced demand. The more capacity you have, the more users start to use it, and in turn they just massively overload the network. So we're probably going to see the same thing happening on Ethereum once all the layer 2 solutions launch, which actually give this linear throughput of the linear boost of 100x. But zero knowledge proofs allow you to build something beautiful, as beautiful as ZK Porter, the architecture we introduced last year, where you can have subtrees of this big state Merkle tree being governed by different data availability solutions. So you can have a shard which acts as a ZK rollup, and all the data is published on Ethereum, and it has full security of slide is also good. It has full security of Ethereum, of layer 1 which it is built, and you can have different shards which have different trade-offs that you might have. Data availability is secured by a sidechain voting, or by some centralized parties, or by some governance councils comprised of some prominent members of the community. But the beautiful thing is they remain fully interoperable. So So first of all, you cannot corrupt the state. You cannot make any, like you cannot steal anything. You cannot corrupt the state. You cannot forge new tokens. The only thing those actors, those shard guardians can do is like freeze the state, which is a lot more difficult to exploit than like if you can directly grab the assets and do something with them. But the beauty is it remains interoperable. You can have protocols deployed on like a super secure ZK rollup shard, which share the security of Ethereum, like 100%. Like there is literally nothing an attacker can do to change the security assumption. And then you can have millions of users living in these various shards with lower data availability guarantees who can still participate with like in the protocols on the rollup. So you can have a Uniswap deployed on the ZK rollup side and all these millions of users interacting with it for a fraction of a cent, or like for a fraction of a dollar. So I don't know what's the implication of this is going to be. I think we will have something like big chains getting bigger and smaller chains losing relevance because of this. So the big chains will have to compete on the most fundamental properties that distinguish them. Like